Hello everyone. In this video we are going to take few examples on sum of arithmetic progression. So here's the first question we're having. What is the sum of the first 15 terms of 3, 5 whole number 1 over 2, 8, 10 whole number 1 over 2, and so on. So here's the solution. Our first term here is 3, so our T1 will be equal to 3, and that's still the same as our A. To get the common difference, I'm going to use the fourth term minus the third term. So we are having our D to be equal to T4 minus T3, and that will be 10 whole number 1 over 2 minus 8, and that will be 2 whole number 1 over 2. Of course, we can write 2 whole number 1 over 2 as a proper fraction by changing it to a proper fraction. So that would be 5 over 2. Now, the formula for sum of an AP is Sn is equal to n over 2 into brackets 2a plus n minus 1 d. So here we are asked to find the sum of the first 15 terms. So we are looking for our S15, and that will be equal to 15 over 2 into 2a. Our a here is 3, so I'm going to write 3 here, plus n minus 1. Our n is 15, so that will be 15 minus 1 d. Our d is 5 whole number 1 over 2. 5 over 2, sorry. So that will be 15 over 2. 2 times 3, that will be 6, plus 15 minus 1, that will be 14, multiplied by 5 over 2. And the 2 here can divide this 14 7 times. So we have 15 over 2 into bracket 6 plus 7 times 5, that will be 35. So we are going to have 15 over 2, 6 plus 35, that will be 41. So now we are going to multiply these two together. That will be 41 times 15, 5, 20, 1, 4, and that will give us 1, 6. So this will give us 615 divided by 2, and that's the same thing as 2 in 6, that's 3, 2 in 1, that's 0, remainder 1. So 2 in 15, that will be 7. So we have 307 whole number 1 over 2. So this is still the same thing as the sum of the first 15 terms. Hence, the sum is 307 number 1 over 2. So here's the second question. The question says, find the value of the arithmetic series 4 plus 7 plus 10 plus 13 plus dash 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 plus 52. Here, this is a series. The main difference between a series and a sequence is that instead of in a sequence you have comma here, instead of plus you have comma, and in a series you have addition there. So now here's the solution. Actually, we are going to treat this as a sequence first. Now, how do we do that? Is that our first term here is 4, and that's going to be our A. For us to get a common difference, we use the formula D is equal to, just pick any term, maybe like third term minus second term. So that will be T3 minus T2, and that is our third term here is 10, our second term here is 7. So we have 10 minus 7, that will be 3. And now, for us to get the value of this series, we need to know how many terms do we have in the series. And since we are not given the number of terms we have in this series, we have to find it ourselves. Then how do we get that? Is that the last term of the series is 52. So we use the formula for the nth term of a sequence to get that, which is Tn is equal to A plus n minus 1 D. We know that our last term here is 52. So instead of writing Tn, we put 52 there. 52 is equal to, our first term here is 4. 4 plus, we don't know the number of terms, so we leave it as n minus 1. And our common difference is 3. So we have this to be equal to 52 is equal to 4 plus, we use 3 to open these brackets, then we have 3n minus 3, so that we now have 52 is equal to 4 minus 3, that will be 1. So we have 3n plus 1. So we collect the like terms and we bring the 1 to the other side. So we have 3n is equal to 52 minus 1. Then we have 3n is equal to 51. So to get the value of our n, we have to divide both sides by 3. So we have, yes, to get the value of our n, we divide both sides by 3. So we have 3n is equal to 51 divided by 3 divided by 3. So this goes with this. And we have 3 here, 1, 3 here, 1 remainder 2. We put the 2 here, 3 in 21, that will be 7. So we have 17. That means the 52 here is our 17th term. That means the 52 is equal to T17. And now, since we are to find the value of this arithmetic series and addition is what is between them, that means we are finding the sum of 17 terms of this series. So we are going to use the formula Sn is equal to n divided by 2 into bracket 2a plus n minus 1 d to get our answer. So now we know that we are summing up 17 terms as we have gotten here. So we have S17 is equal to 17 divided by 2 into bracket. Our a still remain our 4 here, so that will be 2 into bracket 4 plus our n now is 17, so we have 17 minus 1, and our d is 3. From here, we have our sum of 17 terms is equal to 17 over 2 into brackets 2 times 4, that will be 8, plus 17 minus 1, that will be 16, multiplied by 3. So we have 17 over 2 into bracket 8 plus 16 times 3, that will be 48, and this will be equal to 17 over 2. 8 plus 48, that will be 56, into brackets 56. So these two can divide 56. That will be 2 remainder 1, 28 times. So now we have 17 times 28, and we have 7 times 8, that's 56, remainder 5. This is 14, that will be 19, 8, 2. So we have 6, 7, that will be 476 as our answer. So always remember to write your conclusion. The value of the series is the value of the series is 476, and that's our final answer. So here's the third question, and it says the first term of an AP is 3 and the 11th term is 18. Find the number of terms in the progression if the sum is 81. So here's the solution. We are given in the question that our first term, which is T1, is 3, and that's our A. Our 11th term, which is T11, is 18. Now, the formula for our 11th term is T11 is equal to A plus 10D. So that means our 18 is equal to A plus 10D. Now, since the value of our A is 3, so we have 18 is equal to 3 plus 10D. Then we collect the like terms. So we have 18 minus 3 is equal to 10D. And from here we have 15 is equal to 10D. So that the value of our D is equal to 15 divided by 10. And that will be equal to 3 over 2. Now, since we are given that the sum of the progression is 81, the formula for arithmetic sum of an AP is Sn is equal to n over 2 into 2a plus n minus 1d. Sorry. So we know the sum is 81, but we don't know the number of terms. So this will be n over 2. Since we don't know the number of terms, our n still remain n, into 2 multiplied by a, our a is 3, plus n minus 1 d, our d is 3 over 2. So we have 81 is equal to n over 2 into 2 times 3, that will be 6, plus n minus 1 into 3 over 2. So from here we have 81 is equal to n over 2 into 6 plus, we use this to open the bracket now, that will give us 3n over 2 minus 3 over 2. So we have this to be 81 is equal to n over 2 into 6 minus 3 over 2 plus 3n over 2. So 6 minus 3 over 2, the LCM here is 2. So we have this to be 12 minus 3, and that will be 9 over 2. So we have 81 is equal to n over 2, and we know that the value of 6 minus 3 over 2 is 9 over 2. So we have it as 9 over 2 plus 3n divided by 2. From here, we have 81 is equal to n over 2 into 9 over 2 plus 3n divided by 2. Now, 81 is equal to, we use this to open the bracket, n times n over 2 times 9 over 2, that will be 9n over 4 plus n over 2 times 3n over 2, that will be 3n squared over 4. So this is the same thing as writing 81 is equal to 9n plus 3n squared over 4, since the denominator are the same. So we can cross multiply now. We have 81 times 4 is equal to 9n plus 3n squared. And the value of our 81 times 4, that will be 324 is equal to 9n plus 3n squared. So we can take this to the other side to have 3n squared plus 9n minus 324 is equal to 0. So this leads us to quadratic equation. To solve this equation now, we make use of the general formula for a quadratic equation, which is n is equal to minus b plus or minus root of b squared minus 4ac all divided by 2a. 3 is our a, plus 9 is our b, and minus 324 is our c. So we have n to be equal to minus b, that will be minus 9 plus or minus root of b squared, that will be 9 squared, minus 4 into brackets a. Our a here is 3, the coefficient of n squared. C. Our c here is minus 324, the constant term, all divided by 2a, and our a is 3, of course. So this will give us minus 9 plus or minus root of 9 squared, that will be 81. Now, minus 4 times 3, that will be minus 12. Minus 324. All divided by 2 times 3, that will be 6. Now, 324 multiplied by 12, this will be 8, 4, 6, 4, 2. We have 3 here, sorry. So that will be 8, 8, 8, 3. So this gives us, remember, I'm not multiplying with the minus here, but there is minus here. So this minus will multiply this minus and it will become plus. So this will become minus 9 plus or minus root of 81 plus 3,888, all divided by 6. Now, 81 plus this, that will be 9, 6, 9, 3. So we have minus 9 plus or minus root of 3,969, all divided by 6. From here, we have our n to be equal to minus 9 plus or minus root of 3,969, that is 63, divided by 6. So we have our n to be equal to, actually here, we only need the positive root. We can't take the negative root since we are looking for number of terms, and our number of terms cannot be minus. So we only take the positive, which is minus 9 plus 63 divided by 6. And this will be equal to minus 9 plus 63, that will be 54 divided by 6. And that will be equal to 9. So that's our n. Hence, this means the number of terms is 9. That is, we have 9 terms in the sequence. Thank you very much for watching. Remember to like, subscribe, and share.